All right, our last video for today. This one's probably going to be a little bit shaky. I don't have my my document camera. I'm going to go try to pick that up today, so I'm going to be taking the video by hand as I'm writing, so I apologize if it gets a little bit shaky. But I'm looking at the textbook, page 556. I'm going to do a couple of things that you're asked to do in the 9-2. Then you guys should be able to go off from there and go. So if I'm looking at like question number 10 on page 556, it asks to find the equation of the axis of symmetry and the coordinates of the vertex of the graph. So number 10 ends up being y equals x squared minus 8x minus 7. All right, so what am I trying to do here again? Axis of symmetry. Again, I know axis of symmetry is going to be x equals the opposite of b over 2a. And once I get that in there, I'll be able to find the vertex. They're the two things I'm trying to find. So I want to label these guys. A will equal my leading coefficient, which is 1. B equals -8. C equals -7. So to find the axis of symmetry, I just do x equals the opposite of -8, which is 8, over 2 times a, which is 2. So my axis of symmetry is 4. Again, what does that mean? Not that you're asked to do it on this one, but at positive 4, x is 4, 1, 2, 3, 4, I'd have my line of symmetry. And I know my vertex is going to be on there somewhere. That's what that piece of information gives me. So now part 2 of that. So axis of symmetry, x equals 4. Let's find the vertex. Just take 4, plug it into the quadratic. So y is going to equal 4 squared minus 8 times 4 minus 7. Y is going to equal 16 minus 32 minus 7. Y equals 16 minus 32 is -16, minus 7 is -23, I believe. So my vertex then would be 4, -23. Again, now I'm not going to sketch that on the graph, but 4, -23 would be way down here. All right, so that's one type of question. A second type of question that you're asked to do is sketch out graphs. Let's say we did one of these together. Let's plug in, let's do number 11 from your packet. All right, number 11 is graph each function, label the axis of symmetry in the vertex. So if I were to do number 11 from your packet, we have f of x or y, no big deal, that's our function notation, is -2x squared plus 8x minus 10. All right, so what I'd like to do here is label my a, b, and c. A is -2, b is +8, and c equals -10. Now these graphs sometimes take up a lot of space, so just do the best you can with them. And really the important points are the vertex, the axis of symmetry, and then maybe trying to find a point or two other than that, and then we just sketch the parabola from there. But the first thing I want to do if I'm going to sketch out a graph is I want to find the axis of symmetry. That's the first thing. So x is going to equal the opposite of b, or -8 over 2a. 2 times -2 ends up being -4. So this guy ends up being 2. My axis of symmetry ends up being 2. All right, so now let's find the vertex. Let's take 2 and plug it in. So y is going to equal -2 times 2 squared plus 8 times 2 minus 10. Y is going to equal 2 squared is 4 times -2 is -8 plus 16 minus 10. So that becomes 8 minus 10, or -2. My vertex then ends up being 2, -2. All right, so now I want to draw my x and y axis. Let's see where my vertex is. I'm going through +2, -2, okay. It's going to be opening downward as I see, right? That's a negative, so I'm going to put my y-axis up here. I'm sorry, that's my x-axis. So what I would do at this point is sketch my, plot my vertex and sketch my axis of symmetry. So my vertex is +2, -2, which is right here. My axis of symmetry is going to be going right through that. So at this point, what I want to do is just maybe pick a couple of points that are going to be to the left or right of the axis of symmetry, and then use the symmetry to help me graph. So I create a table of values, x, y. Let's see, let's plug in 1. All right, let's plug 1 in and see what we get. When we plug 1 in, we just do the mental math. The calculator's helpful here, but 1 is not going to change anything if I square it, so it's going to be -2 plus 8 minus 10. So -2 plus 8 is 6, and 6 minus 10 is -4. So I'm going to end up at 1, -4, 1, -1, 2, 3, 4. All right, and I know if I plug 0 in, right, I like 0 as a nice easy number, but that's just going to get me this value right there, C, of -10. And you can see that I'm quickly off, almost off my paper. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 would be down here. All right, now, use the symmetry at this point. I don't need to find any more points. If I am 1 away from my line of symmetry, I'm going to be 1 away on the other side. If I am 1, 2 away, I'm going to be 1, 2 away on the other side. And then I just take my pencil, or pen in this case, and I just sketch this rounded U shape going through, and I have it graphed. Okay? And lastly, we'll do one more. Let's say we looked at question dealing with vertical motion. There's one in the textbook. I'll let you do the 2 on your paper. And by the way, when you guys get to your paper, you know, when you get to these over here, just do the best you can with these. I know they start to get challenging with the leading coefficient being a fraction. All right, calculators become your friend there. If you get decimals, just estimate what those values are when you do that. All right, there's nothing much more we can do there. Let's say we were given a problem from the textbook like number 26. It asks, a baseball is thrown into the air with an upward velocity of 30 feet per second. And the model's given to us, h equals -16t squared plus 30t plus 6, which means we had an initial height of 6 feet. How long will it take the ball to reach its max height? And then what is the ball's maximum height? And we'll also find how long it will take to hit the ground. I'll throw that in there too. All right, so it tells us our initial height is 30 feet per, or I'm sorry, our initial velocity is 30 feet per second from an initial height of 6 feet. So h will equal, again, this is number 26 from the textbook on page 557. It's going to be -16t squared, right? -16 always stays there because that's our force of gravity, plus our initial velocity is going up at 30 feet per second from an initial height of 6 feet. All right, the questions here are, we want to find the time it takes to get to the max height. Okay, come here, buddy. We want to find the max height, which are both parts of the, that's basically your vertex. There's our x value of the vertex. This is our y value of the vertex. And then we want to find the time it takes to hit the ground. How long will it take the ball to hit the ground? That's going to just be a sketch on a graph where we're going to estimate that using our equation and try to find when we can get to 0 here for a ball to hit the ground. All right. So, first part, what time to get to, time for the ball to get to the max height. That's basically our time is t, right, which is in our x spot. So x is going to equal the opposite of b over 2a. It really is that simple. All right, I got my calculator here. If you don't have a graphing calculator, no big deal. You don't need it. So I just do the opposite of, this is going to be -30 over 2 times a, which is -32. 30, and by the way, if you get a negative answer here, your time can't be negative, so you did something incorrectly. I just do 30 divided by 32, so the time is going to be 0.9375 seconds. And if we round that, that'd be fine, but that's okay. Now to find what is the max height, we just take this guy and plug it in for time. So h is going to equal negative 16 times 0.9375 squared plus 30 times 0.9375. Again, sorry for me moving this around here. And then plus 6. Go to the calculator, type that in. When I type that in, I just do negative 16 parentheses 0.9375, close it, squared plus 30 times 0.9375, and then plus our initial height of 6. Hit enter, and there's our max height of about 20.06 feet. So H would equal 20.06 feet. Okay, so lastly, if you were asked to find the time it takes to hit the ground, if I were to sketch this out, I'm just going to estimate, okay, estimate when I'm going to hit the ground here. But if I look at this, my initial height is 6. All right, I'm just going to sketch this. So let's say this is 6. And it took us a little less than a second to get to the max height. So let's say here's 1 second, here's 2 seconds. And at 0.9375, we were up at 20. So if this is 5, 10, 15, 20, here's 20 here. So right about here, we're at our max height. I can sort of sketch this out based on my line of symmetry that, okay, it took me this far, like 1 block and a little bit here, so a little bit here and then 1 whole block. I'm going to be down in this area, but let me just plug some numbers in. So if it took me a little less than a second to get up here, if I were to plug in 2, I'm probably going to be in the negatives and I'm going to be done. So it's going to be between 1 and 2 seconds, I would believe. But I just go to the calculator and I would type in negative 16 times 2 squared plus 30 times 2 plus 6. Oh, I'm at 2 feet, right? I'm at 2 right there. So at 2 seconds, I'm 2 feet above the ground. So again, that sketch would go up, and so it would come down. If I did it looks like it's off a little bit. I'm not sure exactly why that looks off. All right, and somewhere maybe a little bit more than 2 feet. So if I check this out and plugged in maybe 2.1, again, I don't need to get real close. I can say it's a little bit after 2 seconds, but if I take that squared plus 30 times 2.1 plus 6, you can see I'm at negative now, which would mean I went below that. So it's a little more than 2 seconds out. Okay, so my sketch of the graph then, if I again, it looks like it's a little bit funky here. It's supposed to have a parabola shape to it. All right, we should be right a little bit more than 2 seconds. Okay, just check those out, do the best you can today, and I'll talk to you tomorrow. Good stuff.